Welcome to queenon7.com. Please like, share and subscribe my video. Today we're going to look at the exothermic and endothermic reactions. We will look at the first, which is exothermic. Exo means out. That means energy is transferred from the system to the surrounding. And a lot of people in GCSE, they just get confused when we talk about system. System can be a test tube or a container or anything which is actually where the reaction is happening. So please do not get confused about that. Now, when we're doing a chemical reaction, for example, if this is your chemical reaction, you are mixing A plus B, and you think the beaker, and if you put that actually thermometer there, if this is the thermometer and the temperature is rising, like you hold in the test tube, or you can just see the thermometer, the temperature is going up, that means the actual temperature is rising within the chemical reaction. That type of reaction are called exothermic reactions. So the definition for exothermic is when energy is transferred from the system to the surroundings. And the example is actually combustion. Combustion is one of the examples when you actually react something with oxygen. So for example, if you have a methane gas which you burn at home to cook your food, it will be reacting with oxygen, it will produce carbon dioxide and water. Now, when you actually burn the gas at home on the cooker, you will see that you will feel heat actually. So that means if you leave your cooker on for gas cooker on for a bit, you will see that the temperature goes up because the energy is coming out and it transfer from the flame to the surrounding. So that type of reaction are called exothermic reaction. And the energy, for example, if it's producing 890 kilojoule per mole energy, we will actually represent it with minus, because the energy is actually coming out of the system, out of the beaker, out of the test tube. So it is a loss of the energy, because the law of conservation of energy says the overall energy change will remain the same. From the reactant to the product, the energy actually can be transferred, but you cannot destroy or lose the energy or ignore the energy. Now, based on that, one of the example is in your body we do respiration. So for example, if you have a glucose H12O6, glucose actually in your body can be provided by actually eating food. It is going to react with the gas oxygen, which is actually come from breathing. It goes into your lungs and will be delivered through your bloodstream into your cells via diffusion. So when you actually have glucose with oxygen, it will produce carbon dioxide. When you breathe out carbon dioxide, inhale oxygen, and you will produce water. Now, along with these two inside the cell, you also produce some energy as well. That energy actually helps you to keep going, because when you do some work, you need energy. And this is how you get the energy, by using glucose. So you will produce energy along with it. Now, the system which produces the energy is actually been lost. That means you actually use that energy, so that whatever the energy is produced, it will be represented by the negative value. It will always have negative value if it is an exothermic reaction. Now, let's talk about endothermic reaction. If endo means in. Same goes for in terms of this. If I put, for example, if I have a beaker and I put calcium carbonate, any carbonate, and if I start heating up and produce CaCO3, it will undergo decomposition. It will produce calcium oxide and carbon dioxide. Now, in this case, basically, you have to heat it up. If you heat it up, the energy actually is going into the system, and the whole and overall product will actually absorb that energy. So energy gone in the system. So the energy is gone into the system, and that type of reaction is called endothermic reaction. Now we can define it as when energy is transferred from the surroundings into the system. Please do learn this language, the tier 2 and tier 3 words, that how you actually structure your sentence by using these words. Don't just say energy goes in. The examiner is actually looking for the specific word. The energy is transferred from the surrounding. Surrounding means around the system. Your system can be, as I explained before, it can be a beaker or it can be a test tube. So if the energy is going from outside to your system, that will be called endothermic reaction. Now the example we have already taken one example, calcium carbonate, but we can actually reverse the whole thing again. For example, one of the example is photosynthesis. Photosynthesis is actually the reverse of respiration. So respiration is burning sugar, so which produce energy, which is exothermic. Photosynthesis opposite. It happens in the plants. And plants will actually produce food for us, and a food will contain obviously sugar. So plants will actually absorb carbon dioxide from air. They will take the water from the roots, but they also absorb the energy from which is sunlight. So sunlight will provide the energy from the sunlight, and that will produce again the opposite of this, C6H12O6. And it will produce oxygen as an extra product. That's why plants are very important if we want to increase the concentration of oxygen in air. Because the energy actually being provided by the sun, so photosynthesis is actually a type of endothermic reaction. If you go and touch these plants, leaves and all that, they're quite cold. So that means the energy is actually being absorbed by the system. So one example will be the photosynthesis. Please do like, share and subscribe my videos. I will be uploading some more about the endothermic and exothermic, but we will look at the reaction profiles, how we can represent both energies when we talk about the reaction profile. Thank you.